Alright class, so we're looking at chapter 4.2, combining functions. So, we've got a whole bunch of different ways we can combine functions. We can have the sum of two functions, the difference of two functions, and the product of two functions, and the quotient of two functions. So, the sum of two functions, f and g of x, is the same thing as f of g of x plus, or f of x plus g of x. The difference of two functions, f minus g of x, is the same thing as f of x minus g of x. The product of two functions, f times g of x, is the same thing as f of x times g of x. And the quotient, and yes, that probably should be closed here. Get this to work. Should be a closed parentheses there. F over g of x equals f of x over g of x, where g of x cannot be equal to 0 because we can't have a 0 in the denominator. Now, let's look at the first example. It says, example, we have f of x equal to the square root of x and g of x equal to x to the third. Let's find f plus g of x. So, if we start here, f of x plus g of x is essentially what this is equal to. Okay, well our f of x function here is the square root of x. Our g of x function here is x to the third. Now the big key here is to try to simplify if you can. Here we can't simplify at all. This is just as simple as it gets. So we'll just leave it as this. This is our answer. So f of x plus g of x, or f plus g of x, is just a square root of x plus x to the third. If you can simplify, please do so. If you can't, then you just can't. Now let's look at f minus g of x. Okay, it's the same thing as f of x minus g of x, which is the same thing as the square root of x minus x to the third. Once again, we can't simplify here, so this is simply our final answer. Now if we look at f times g of x, then it's the same thing as f of x times g of x. Okay, so our f of x function is the square root of x, our g of x function is x to the third. Now we should be able to simplify this one a little bit. Okay, now the square root of x is the same thing as x to the 1/2. When you multiply two things that are the same, you can just add their exponents. So this is x to the 3 plus 1/2, which we're going to want to reduce, which means you'll have to find a common denominator. If you find a common denominator for 3, it needs to have a denominator of 2, so 3 is the same thing as 6 over 2. 6 over 2 plus 1 over 2 is 7 over 2. So that, oops, wrong green. What you get is x to the 7 over 2, and it's that simple. Alright, now let's look at f over g of x. So that's the same thing as f of x over g of x. Alright, now if we do this, we take our f of x function, which is the square root of x, and we put that over our g of x function, which is x to the third. Now it's very possible that they'll be okay with the answer looking just like this, but if you wanted to try to go ahead and simplify, you would have to subtract these exponents here. So you got x to the 1/2 on top over x to the third on the bottom. If you wanted to simplify that, you need to take the half to the bottom. So it'd be 1 over x to the 3 minus 1/2. Okay, and then you obviously have to do your change of base again here. So we'd have a 6 over 2 minus 1/2 would be a 5 over 2. So we get 1 over x to the 5/2. Okay. Alright. Now in the next example it says f of x equals x to the third and g of x equals x minus 1. Okay, so let's do this addition here. So it's the same thing as f of x plus g of x. So x to the third plus x minus 1. There's really no simplifying here, so this is our final answer. Now, if we're subtracting them, here's where you have to be careful. You take your f of x function here, which is x to the third. You subtract your entire g of x function, which means you really need to keep that g of x function in parentheses, at least to start with. Now we're going to have to distribute this negative to both, okay? And that's usually where people mess up, is they only distribute it to the first term instead of to everything. So that what it simplifies to is x to the third minus x plus 1. And that's our final answer. Now if we look at f times g of x, then we're looking at x to the third times x minus 1. Now we're going to want to distribute that x to the third and simplify. So I'm going to get an x to the fourth minus x to the third. And that's as simple as we can get it, and that would be our final answer for f times g of x. Alright, I believe we have f of x over g of x next. We do. So we get an x to the third over x minus 1. Now, there's really no simplifying to do here either. So you would just leave that as your final answer. Alright, so if we look at a revenue cost profit example, it says the demand for a certain electronic component is given by P of x equals 1000 minus 2x. Producing and selling x components involves a monthly fixed cost of $1,999 and a production cost of $4 for each component. A says write the equations that model total revenue and total cost as functions of the components produced and sold in a month. Okay, so if we look at revenue and cost. Now, revenue is given by, let's label it R of X. And it's found by taking your demand and multiplying it by an X, or how many you wind up selling. So our demand is 1000 minus 2X. If I multiply that by X, it'll give me the revenue that I make depending on how many number of items X that I sell. If I look at the cost equation, C of X, now your cost is going to be made up as the fixed cost, so you're always going to have a fixed cost of $1,999 per month, and as well how many components you make. There's an additional $4 for each component that you make, so your cost is made up of that $1,999 plus that $4 per each component made. Alright, B says write the equation that models the profit as a function of the components produced and sold during a month. Essentially what you've got is profit equals revenue minus cost. So that what you get is capital P of X for your profit equals capital R of X for your revenue minus capital C of X for your cost. Alright, now we have those functions, so we can do that. It's pretty simple. So what we're going to wind up doing is 1000 minus 2 times X minus our cost function here, which is 1999 plus 4X. Okay, and we definitely have to simplify that. So I'm going to do it up here. I'm going to say OK. Now that'll be 1000x minus 2x squared minus 1999 minus 4x. Okay. Oops. It's an x right there, guys. Okay. So that what it simplifies to is basically I have to take this 1000x and subtract it from 4x. So what I wind up with is negative 2x squared minus, or sorry, plus, oops, go on now, go, so back to it, plus, now we still have 996x minus 1999. Okay, so this is the function we're looking at here. Now in C it says find the maximum possible monthly profit. Now the easiest way to do this is take this function we just found, y equals negative 2x squared plus 996x minus 1999. Take that function and we're going to plug it into our calculator and find the maximum. That's the easiest way to do it. So let's go over to the TI really quick and let's find this maximum point. So I've gone to my y equals, I've got my equation typed in, negative 2x squared plus 996x minus 1999. So what I'm going to start out with, I'm going to zoom standard, okay, and you're not really going to be able to get a good view of it when you do that. But from zoom standard, I'm going to do zoom fit, which is 0, okay. And I still don't get a good view of it. This right here is just left over from whatever I had in my stat plot. You can turn that off by going to second stat plot and then turning it off if you don't want to see that on your screen. You still need to get a better view of this so you can find the maximum point. So I'm going to do zoom and then I'm going to do zoom out. Okay, and my maximum point is somewhere over here to my right, so that's where we're going to scroll. Okay, and I'm getting closer to my maximum point. I'm still going to scroll almost all the way to my right and up at least to the line or kind of near the line to see if I can see where it starts to peak at. And you're probably going to have to do this a few times in order to actually get around the peak of the graph. And there it is. So we can see the peak of our graph here. So what I'm going to do next is second calc, maximum. Okay, I'm going to go left of where the maximum point is, hit enter. I'm going to go right of where the maximum point is, hit enter, and I'm going to guess what the maximum point is, probably somewhere about right here. Hit enter, and it tells me that my maximum point is that x equals 249 and y equals 122,003. So what that means is the maximum that I can make is if I make 249 units, and my maximum profit is going to be $122,000, $122,003. So that's how that works. So let's go back to the paper and put all that down. Alright, so our point was 249 and 122,003. Now it asks for the maximum monthly profit. So what I'm actually looking for here is my y value, which would be this 122,003. So my answer here would be 122,003. Okay, that would be the answer I'm looking for, because 249 is the number of units produced. Now if we move on to page 3, it says average cost. It says a company's average cost per unit when X units are produced is the quotient of the function C of X, the total production cost, and the identity function I of X equals X, which is the number of units produced. That is, the average cost function is C bar, which is the average of C, which is C of X over X. Okay. So in our example, it says Mobley Greenhouses produces transplants. Their total cost for the production of X thousands transplants is C of X equals 50X plus 500. It says form the average cost function. Okay. Now the average cost function, C bar of X, is just equal to C of X over X, which is pretty simple here. It's just 50X plus 500 over X. Now if you wanted to reduce this, you could try to reduce it. You could cancel an X here and still have a 500 over X. I'm just going to leave it as this. This is simple enough for me. Okay. Now it says for what input values of C bar, or for what input values is C bar defined. Now this is a little more tricky here. Now technically speaking, X can be anything but 0, right? Can't have a 0 in the denominator. So we know that X cannot equal to 0. Alright, but if we think in terms of the actual problems, is it actually possible for Mobley Greenhouses to produce a negative number of transplants? It's not. It's a word problem, so you got to think outside the box a little bit. So your technical thing here is X has to be greater than 0. Okay, so we've gone from here to here. Definitely doesn't include 0, which this shows. It has to be greater than 0. Now, the other thing you have to think about is, okay, can Mobley greenhouses produce half of a transplant? So no, it can't. Okay, so that means that what really needs to happen is x has to be greater than 0 and x has to be an integer. So x is an integer that's greater than 0. Okay, so you can really narrow this down. So x has to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, x can't be 0, can't, because x is in the denominator. X can't be a half because you can't produce half of a transplant. Okay, now it says graph C bar for 0 to 5,000 x. What can you say? Okay, so let's go into our calculator. Let's graph this between 0 and 5,000 on our x-axis and see what we can say. So I'm going over to the TI now so that I can put this in and we can see what it looks like. Okay, so looking at the calculator here, I've already typed my function in. And the important thing is to make sure whatever's in the numerator is in parentheses and then you divide by x. Otherwise, it's going to think the only thing you're dividing by x is 500. Okay, now once you do that, it said your x needs to go from 0 to 5,000. Okay, so we'll go to our window and change x from 0 to 5,000. Now the next thing I'm going to do is hit zoom, and then I'm going to do zoom fit. And what that'll do, believe it or not, is in your window it'll keep this 0 to 5,000 for your x, but it will adjust your y so that you can see a very nice graph of it essentially. Now what you will notice if you're looking at your window for y is your y min isn't a 0, your y min is a 50, and your y max is a 63. So you're not as close to 0 here as you might think. If you did want your y to be 0, you could adjust that accordingly. So you could make it 0 and then graph, and what you see is, okay, now it's not going to go down and cost nothing to do this, but it will go down, in at least initially, and get significantly cheaper. So what's happening here is if you order a very small number of transplants, it's going to cost you a lot. But the more transplants you order, the cheaper it gets, up to a point to where it kind of flattens out. Okay, so at some point it flattens out, and no matter how many transplants you order, it's basically the same price. Okay, it doesn't decrease down to 0. It kind of evens out and approaches a number. Now we don't do limits in this class, but if you go into calculus, you will do limits, and it essentially approaches a limit here, and that's something you'll talk about more in a calculus style course. All right, but what we can see is the more transplants we purchase, the better off we are as far as getting a better price per transplant. Easy enough. Let's go back to our notes. Alright, so the next thing we'll look at is composite functions. Now, a lot of people confuse composite functions with multiplying two functions. That's the biggest mistake that I probably see. Composite functions is different in that it's f of g of x, not f times g of x. And when you do f of g of x, you essentially put your g of x function in your f of x function, wherever your x is supposed to be. Okay, so the composite function f of g is denoted by f of g, and it's defined by f of g of x equals f of g of x. Now the domain of f of g is the subset of the domain of g for which f of g is defined. The composite function g of f is defined by g of f of x, which is equal to g of f of x. Now the domain of g of f is the subset of the domain of f for which g of f is defined. Okay, now let's do some examples because I know all those words can kind of just come out like gibberish to most people, even when I read them and even when they read them to themselves. So let's just put pencil to paper here and show you how these examples work. Biggest thing to notice is this is h of f of x, not h times f of x. Okay, so be really careful on the symbol right here. Okay, so the first one, h of f of x. Essentially what we're going to do is we're going to take our h function here, which is 1 over x. I'm going to go ahead and write the 1. Now where this x is at, I'm going to put this f function. Okay, And then I'm going to simplify if possible here. It's not possible to simplify. This doesn't simplify at all. So this will be my final answer. If it helps, essentially what I did is h of f of x. Everywhere there was an x in h, I put the f of x function. Okay? Alright, let's do f of g of x, which is the same thing as f of g of x. Okay, so it means I'm going to take my f function and I'm going to start writing it. Everywhere I see an x, I'm going to put my g function. So there's an x next to this too. I'm going to put my g function there. I'm going to do it in parentheses. And then I'm going to add my minus 5 to finish off my f function. Now I do have to simplify this one. 2 times 6 is 12. Minus 2x squared minus 5. 12 minus 5 is 7. So what I get is negative 2x squared plus 7. Okay, so that this here is my final answer for f of g of x. Now f of g of x is different than g of f of x. I think you'll see this in this next part. So g of f of x means that I plug my f of x function in for every x in g. So that I start with my g function, which is 6 minus x squared. So I see that I have an x here. I'm going to plug in my f of x function for each one of those x's. So that I get 2x minus 5, then squared. Now I do have to simplify this. So I get 6 minus, now you remember 2x minus 5 squared is the same thing as 2x minus 5 times 2x minus 5. Okay. Now we have to FOIL that out. I'm going to leave the negative out front. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is positive 25. Okay. So that what I get is 6 minus 4x squared minus 20x plus 25. Alright. Now I need to distribute this negative. So I get 6 minus 4x squared plus 20x minus 25. Do a final simplification here. I've got a 6 minus a 25 is going to give me a negative 19. So that my final function looks like negative 4x squared plus 20x. Okay. My handwriting's getting bad. Oh, add notes. Okay, that's fine. This is an x. And then we said minus 19. Alright, and that will be your final answer for g of f of x. Alrighty. Now in the next example it says f of x equals the square root of x minus 5 and g of x equals 2x squared minus 4. Okay. It says compute f of g of negative 3 and compute g of f of 9. I want to change colors here just to distinguish from what we were doing above. Okay, if I'm looking at f of g of negative 3, there's two ways you can do this. I'm going to do the first one way, the second one another way. Okay, and you choose whichever works best for you, whichever method you like best. So the first method that I'm going to do, we've got f of g of negative 3. Okay, so in the first method, what I'm going to do is I'm going to keep it all together. Okay, which means I'm going to start with my f function here. I've got an x here and I've got a g here, so I need to plug in this 2. And I've got a negative 3 here. So I need to plug that negative 3 in for my x squared minus 4. And then I do have to remember that I've got this minus 5 in here as well for f of x. Okay, and now I can go about simplifying. So if it helps, the colors, this and this are from my f of x function. Okay, this is from my g of x function, and surely I can find one more color to distinguish here. Let's do a yellow. And this negative 3 is because I have a negative 3 in for my x right here. Okay. Now, like I said, you might not like this method. If you don't, fair enough. I'll show you another method. But let's go ahead and simplify. Okay. So, negative 3 squared is going to be a positive 9. Okay. Negative 4 minus 5 is negative 9. Okay. 2 times 9 is 18. So I get 18 minus 9. 18 minus 9 is 9. Square root of 9 is 3. Okay. So that would be your answer here. Now, if I want to look at g of f of 9, okay, g of f of 9, then if you want to look at doing it in the second method, so if I change my colors maybe to orange, I'm looking at g of f of 9. That's the same thing as g of f of 9. Now, in this method here, what I'm going to do is I'm going to go ahead and find f of 9. Okay, so I'm going to take my f function here, which is the square root of x minus 5. I'm going to plug in 9 for x, so that I get 9 minus 5 is 4. Square root of 4 is 2. Okay, now I'm going to take this 2. I'm going to take this 2. Because it's equal to f of 9, I'm going to put it right here in place of f of 9. So that what I get is g of 2. Okay, so now all I have to do is plug this 2 into this g function. So I get 2 times 2 squared minus 4. Okay, 2 squared is 4. So I get 2 times 4 minus 4. 2 times 4 is 8 minus 4. 8 minus 4 is 4. So my final answer here is 4. And that's the second method you can use. You can use either of those methods. If you have a kind of another method of solving it, or kind of an in-between of two, that's just fine as well, as long as you're getting to the right answer. But those are the two methods I show, and the two methods that I use to go about approaching doing this, or I suggest using to approach doing this. So if you have another method, by all means, as long as it works, you can use it. But if it doesn't work, obviously, don't use it. If you have any questions whatsoever, please send me an email. Try your homework. Let me know if you have any questions at all on the homework. And hopefully you're getting along well so far in the course. And like I said, any questions, send me an email. Other than that, jump on, finish your homework, and jump to chapter 4.3. Thanks for watching.